Today, we are going to continue with our review, getting ready for next Wednesday's test. A reminder that this test is the one you want to do well on. Okay, the course is going to get more difficult, so you want to make sure you're setting yourself up for success with this first one. Okay, a little bit different bell work. I stole this one from an AP exam. The graph of the piecewise function is shown. What is the value of the integral of 0 to 12 f prime of x? Okay, so maybe your first inclination is to find the area under the curve. But why doesn't that work here? It's a graph of f. It's asking you to find the area under the curve of f prime. So there's two different things you could do. I will do it one way, and then I was listening to Max talk to what he did, and he did a great thing as well. Let's look at this. This is the integral. If I asked you to find an integral, what would you do with the function? What do you do with a function when you're doing the integral of it? Antiderivative. Everybody agree with me? You would find the antiderivative. What is the antiderivative of f prime of x going to be? F of x. That is the antiderivative. And then you would then evaluate that thing from 0 to 12. So we would do that. It's going to be plug in the upper bound minus plug in the lower bound. What is f of 12? How could I find that? Look at the graph. F of 12 is -4 minus f of 0. F of 0 is 4. -4 minus 4. The answer is -8. It is a question that at first glance looks really crazy. Okay? It looks like, hey, I don't know what to do. But sometimes when you get to a multiple choice question, just do the problem. Hey, I see an integral. What do? I find the antiderivative. Oh, that gets me f. Then I plug in the upper bound and the lower bound. And then sometimes it just comes to you. Okay? That's what's happening there. I like what Max did here. He actually graphed the antiderivative. Okay? Or you graphed the derivative, right? He graphed the derivative because he's graphing f prime. Well, f prime right here, you could do it only on this one because it was straight lines. If it wasn't straight lines, this wouldn't work. But he said, all right, the slope right there is -1. So the graph would look like this up until 6. And then, up until 7. And then from 7 until 8, it's 3. Because the slope is 3. So we'd have a line like that. And then from there until there, it is -1 again. And so what he did was he found the area under the curve, -1, -2, -3, -4, -5, -6, -7. Then he had +3 because he went up above. So -7 plus 3 would get him -4. And then he would have -5, -6, -7, -8. I do not suggest doing it that way. But notice that it matches. Okay, he looked at the derivative and then found the area under the curve of the derivative. The other way is easier, but I like both ways. Questions on something we did there? Okay, four corners activity. I love four corners. They are not going to work exactly the same as I would if we were in a regular classroom. Okay, but remember how four corners activities work. It's all about seeing the same problems in 4 different ways. In the top left, you have a graphical version. The top right, you've got a tabular version. You've got a table. Bottom left, you've got an algebraic version. And the bottom right, you've got conceptual. Okay, and so think about that as we work through it. Here's how we're going to break this down. All right, here we go. So if you are at home and you are watching this, I'm going to go through the answers now. So don't do this until you've actually done it. But for people in class, let's check our work, see how you did. There is number 1 and 2. Oh, that's the wrong answer key. Let me find the real answer key. That's the right answer key. Check your work there on 1 and 2. See if you agree. Okay, I know you worked with your neighbor, but you might not have gotten a great explanation. Look at those answers. See if you agree. If not, ask me a question about them. First one is 8, not 7. Questions on any of those? Make sure the second one, probably the most important part, is the description. When I integrate, okay, I found the integral of r prime. R prime was meters per second. When I integrate it, it is going to tell you the change in an amount. When you integrate a rate, it tells you the change in amount. So that is the change in meters from 2 to 11. Okay. On 1D, that was the one that we had the most questions about. This +1 is shifting your graph to the left. Okay, so think about what that means. I didn't want to delete that. That means you are finding the area from 0 to 2. But I'm shifting the graph to the left. So that means every point on this line is going to go to the left. So that means this point goes to the left one, and this point goes to the left one, and this point goes to the left one. Or in other words, it's like finding the area from 1 until 3, because that would be what would now be from 0 to 2 once I shift that graph to the left. That's a little bit more challenging, but it's good for you. Questions with anything on the first two? Anything else? Yes, ma'am.
I know that it shifts the graph to the left, but could you just think about it like it shifts each of your bounds?
Absolutely. You could just think about it as shifting the bounds. Instead of 0 to 2, it's like 1 to 3. It's like literally taking your x value and adding 1 to it. That's what we're doing. Okay, down below, there's those two. We got 8 on number 3 and 17 on number 4. Check to see how you did. The biggest mistake you would make on 3 is just the arithmetic stuff, the adding and multiplying and dividing, raising to a power. Be careful there. Make sure you have everything in parentheses. See how I distributed that negative? That's key. On number 4, the annoying part on number 4 is it tells you that at t equals 0, the particle is at x equals 3. And so normally we have an xy ordered pair. Stupidly here, we have a tx ordered pair. T is my independent variable. It's my x value. And then we're calling this x because you're moving along the x-axis. Okay? It's really my position, so it's really my y value. It's really weird and annoying, but they do that every once in a while on the AP exam. That's why I'm throwing it at you. Okay? But here we found the antiderivative. We then plugged in 0 and 3 to figure out what c is. Then we plugged in c, and then we plugged in 7 to find position. Other questions through number 4? Cool. Some stuff. Let's look over the other side here. So if we're looking at the answers, here's what you should have gotten on 1 and 2. On number 1, negative 2 pi, 1 minus 2 pi, 6 minus 2 pi, and negative 2. This one's a little bit more challenging. Part D, I like to make the hard ones on part D. For number 2, we did a right Riemann sum, but it was an average. Okay, some of you love to say average, even when it's not average. This is an average because I have the 1/10 in front. When you multiply by 1 over whatever your bounds are, that is an average. So what we found here, because I integrated temperature, what I found was the average temperature in whatever units I started with over that time period from 0 to 10. Yes, sir? I did a left Riemann sum, when in reality I should have done a right Riemann sum, because no one would want to do a left Riemann sum. We throw a 5 in there, we throw a 2 in there, we throw a 0 in there, and a negative 3. Sorry. What's my value going to be then? 3, and so this is 3/10. Yeah. Am I good? Sorry. Thank you. Other things? Questions on 1 or 2? There's 3 and 4. Number 3, it was just a straightforward algebra problem. Okay, once we do the antiderivative, this is the only calculus involved. Once you've done this, it's just a, can you do the algebra? So we did that. We plugged in our upper bound of 4. We plugged in 4 into everything. And then we plugged in a 1 into everything. You've got to be careful when you subtract that you are distributing that negative out. Okay? Being able to work all the way through that is not exciting or fun, but you got to be able to do it if it were a multiple choice question. Issues there? Yep.
Is there an answer to the
for this thing?
No, for the packet.
The packet is not posted yet. Yes, sir. Yeah, so when I combined stuff here, I did 64 minus 8 and then minus 1 there. And then plus 2. Yeah, sorry, I forgot my plus 2. On number 4, they started off by telling us acceleration. And they wanted us to figure out what the position equation was, an expression for position. So we started off. We found the antiderivative acceleration. It gave me this plus c. Then I plugged in what I knew. Okay, I knew that at t equals 0, the velocity is 2. So I plugged in 0 and 2. I solved for c. That's my new equation. But I didn't want velocity. I wanted position. So then I found the antiderivative again. So when I found that antiderivative, it gave me this guy. It's got another plus c. But I know at t equals 0, the position is 5. So I plugged in 0 and 5. I figured out what c was. That was what I was looking for in the end. Questions with something there? It's different, but it's a good practice for you. Harder.